Alright, here's our second example, working with the difference quotient again. This relationship here, remember, is the difference quotient. So here's a specific function we want to apply it to. Like in my previous example, I'm going to go ahead and break it into pieces here. So f of a plus h, let's do that. Well, f of a plus h, that just means to go and put a plus h in for x. So that would be a plus h squared plus 5. Let's go ahead and evaluate that. Let's simplify. I kind of just jumped over it in my previous example, so let me elaborate a little bit more here. So a plus h squared, here's a really common error I'll see pop up. I'll get students just write, oh, that's a squared plus h squared. Well, we're missing something if we do that. So remember, that means a plus h times a plus h. So you need to multiply this out. So a times a gives us a squared. A times h would be ah or ha. And then we do the second one. So h times a is another ha. And then h times h is h squared. And then, of course, we still have our 5. Well, notice these are like terms. We can combine those. And so we get a squared plus 2ha plus h squared when we multiply that out, plus 5. Alright, now of course, minus f of a. So we did this part. Let's do the second part. Well, nothing's changing. We're just going to put an a in for x, and we're going to subtract this whole thing. So that would be minus x squared, minus a squared. Trouble with using pen here, but it shows up better in my videos. So a squared minus 5. Now let's put them together and actually use this relationship here. So we've got this whole thing and then this guy. So a squared plus 2ha plus h squared plus 5 minus a squared minus 5, and that's all over h. So a squared minus a squared will cancel, 5 minus 5 will cancel, so we're left with 2ha plus h squared over h. Notice we can take an h out of this top terms, so h times 2a plus h over h. My h's divide out, and I'm left with 2a plus h, and there is the difference quotient. We've got a couple more coming up that we're going to try.